I find Wikipedia fascinating, and there's one idea that I've been having for quite some time already, which is to make a clone of Wikipedia. Like I want to clone it on my own machine, could be my server, could be my local computer. So if you go to this website, meta.wikimedia.org /wiki/data torrents, you're gonna find some torrent links. And if you look at this file, so this is multi-stream, and if you take this one, so if you take this file, it's 16 gigabytes. However, it's compressed with bzip2, and after uncompressed, so I have downloaded this file. Actually, I have an older version here from 2019, and uncompressed, it goes to 70 gigabytes. That's 70 gigabytes. It's a lot of data. It's one big XML file of 70 gigabytes. It took quite some time to download. I'm not gonna download this more up-to-date version because I already have it here. In fact, the file is so large that it doesn't even fit on my computer disk, and therefore I have it on an external drive, and I have it here in Ruby. So I just opened a Ruby terminal with IRB, and then I did this. So file open, and then the path to the file, and you can see this one is from 2019. It's the pages articles XML file. So it's exactly this one. So that means it's the Wikipedia in English, and then the date of the dump, and then pages articles, which means it's gonna have every Wikipedia page. So I think this file, I haven't counted all the entries there, but I think there are like 53 million pages, because it's not only one page for each article in Wikipedia, but also like if you go to Wikipedia and I don't want to go to any random thing here, and so this is a page, but if you click on a picture, the picture is also a page. So I can click here, more details. And this thing, as far as I understood, it is also a page. Although the file itself is not included in this dump. Otherwise it would have been much, much larger. Maybe this one. I don't know. Haven't tried it. But yeah, the problem with is that the file is so huge that you cannot open it. Although it's an XML file, it's a text file, you cannot open it in any text editor because it would crash it. You try to read it on your RAM, and it would probably crash your computer, would crash the editor or something like that. So to read it, I'm doing this. So to have just an idea on how the file looks like, I'm using Ruby for that. So I'm opening the file like this. I'm not doing read because this would try to read 70 gigabytes on my memory, which I do not have 70 gigabytes. So I'm reading it like this. I open the file, and then I do, so F now holds my file, and I put this nil here. So this is one command, and then it's executing another command, which is nil. Because I don't know if I just press F here, or just this thing, it would maybe try to read the file and print it on the terminal, and that would crash the terminal, and I don't want that. So what I want to do is I want to read the file in small chunks. So I'm going to read, with this, I can read, let's say 16 kilobytes of the file. So 16 kilobytes. It's going to read only 16 kilobytes. Yeah. So there it is. And now it's on the variable s. So I want to actually put s. So it's going to print out the line breaks. And there you go. So here you have the beginning of the file. The first, this is the first 16 kilobytes of the file. All right. So it starts with MediaWiki, goes to this structure here. All right. So from here, I can see the basic structure of the file. So there's no, or maybe there is some documentation on this, but I couldn't find it describing exactly what each field is. But anyway, it's not too difficult to infer it. So the first thing here is a media wiki. So that's the root element, the first one. And then there's the site info, which I don't care about. And then after them, and there's this page. And this page is direct child to the root element. All right, so you can see there's a page here. It begins and ends here. And it has like accessible computing. It's a title. All right, and then it has some, I don't know what this NS here is, and there's an ID, which I suppose is the ID of the page. Then there's this redirect tag, which I'm gonna go into later, and there is the revision here. The revision begins and ends here, so you could have multiple revisions, but I figured that in this file there's only one revision per page, and I think every single page has exactly one revision, no more than that. So I want to actually use this one. Actually, this is not going to be a good example, because so if I go and access this by the title here in Wikipedia, I'm going to find out that it's going to redirect. So look at that, it redirected from this page, because this page is actually a redirect. So this is going to redirect to the page with the title Computer Accessibility. All right, that's what happened there. And well, I'm going to then start on the second one, which is not a redirect. So it does not have a redirect tag, and it's Anarchism. So if I go to Anarchism, and if you take a look here, so there's this ID, and then there's the revision, and the revision itself has also an ID, all right, here, and it has a parent ID, has a timestamp, a contributor, and well, and then it has this text, and the text begins here, and ends here. So the tag declaration begins and ends here, and here's the content. And then if you go all the way to, well, it has more than 16 kilobytes. So let me actually read more of this file, and if I just read again, I'm gonna continue reading where I stopped. So I rather want to go to the beginning of the file again, which I can do with seek, and then read, but instead of reading this amount, I'm going to read like 64 kilobits or kilobytes, and then print that thing. And well, still talking about anarchism, and it didn't end. So again, gonna go to the beginning of the file, and I have to read more. I'm gonna read half a megabyte. All right, that should be enough. So I'm gonna try to find the end of the page by using this trick. All right, so still talking about anarchism, and this is the first, the second end of page. The first one is from that, come on. Yeah, the first one is from, oh no, yeah, this is confusing. Anyway, this is the beginning of the anarchism page, and that's a content. All this is the content of the page. And the format of this content is just the format of a Wikipedia page. So that doesn't matter on this video. I'm not gonna talk about that, because parsing that is a whole different story. What I do want to talk about is that if you read here, anarchism is a political philosophy. So here on the Wikipedia page is saying anarchism is a political philosophy. And here it is saying the very beginning. So these are some meta things here, but then here it is. Anarchism is a anti-authoritarianism political philosophy, so it's different. Here's the political philosophy part, but there was this thing which is not there anymore. And the reason is because, well, I'm filming this on 2021, and this file that I have here is from 2019, almost 2 years ago. So it's almost 2 years ago. It's actually, yeah, almost 2 years ago. So if you go to the page and you click here on View History, here's going to be a lot of revisions. So you can see it's a revision history, and you can compare revisions. So there's a lot of edits. So each edit to a page is gonna generate a new revision of that page. All right. So in this file here, you got only one revision. So only, I suppose, the latest revision, or the revision at the time of the dump of this thing. All right. So that means that this revision is from 2019. So I could go here and try to find it. But I'm not gonna do that. Actually, if you want to read older version of this article, you just go and click here, and wait. All right. So then you see that there's some information here, and here on the URL, you can see that there is this old ID. So if I take this very ID here, which is the ID of the revision, and I paste it here, what's going to happen? Well, of course, what's going to happen is that we're going to see that this version that we're seeing here. All right. So let me put this here. So you see the kind of the beginning of the text matches now anti-authoritarian, which is here. And if you look at the timestamp, it's 19 of July. So here it is saying that this is an older version at 3:54, which is here, 3:54 of 19 of July 2019. All right. So this is exactly this revision. This is the revision we are seeing here. And the contributor, so who made this, and here is the IPv6 address, which is also here, oops, on the page. And here is the text, naturally. Cool. So enough talk. What I actually want to do now is I want to read this whole file. I want to read this 70 gigabytes file. And I've been playing with it already, and I know it's not going to be so easy. So the major problem is the f.size, which is this large number, which if I divide by 1024 to the power of 0 is going to be the same number, because this is just going to be 1. So this is going to give me the amount of bytes. This is going to give the amount of kilobytes, of megabytes, of gigabytes. So actually 68 gigabytes. And well, maybe you want to read about the difference between gigabytes and GB. I suppose that's how it's called, Gigabytes. Which is, you see, the difference is the base here, but I don't want to talk a lot about this. But yeah, this would be technically 68 GB or GB bytes. And if I would change the page to this would be 73 gigabytes or gigabytes. I don't know. Anyway, back to the article. So Wikipedia doesn't matter now, and I want to go and print again that structure of the file. So the way I'm going to read this, and the idea is to read it all, and save it somewhere. So this is the first half a megabyte of this big file. And the challenge here is that usually what I use to read a file on Ruby, I would use a gem called Nokogiri. So this is a gem used for reading XML and also HTML. This is used everywhere. You can see the amount of downloads is huge. So usually if you're reading a XML file, what you do is you read the whole file into memory and then you pass it to a parser, to a DOM parser. So DOM is document object model. So it's going to transform the XML into a object model. So a lot of Ruby objects of that document. All right, so you can then make queries, navigate on that file and read the data from there. The problem is that this is not going to work because this file is so big. So we don't have enough RAM to read that. So what we need to use is a sax parser. A sax parser is kind of a streaming parser. So it's kind of like you process the file at the same time you read it. So instead of reading it and creating the document and operating on that document later, you just read the file, go reading it, and as you go, you process it, you extract the information from the file. So that's what a sax parser does, or allows us to do. And the difference is that it does not. So it reads the file, but it allocates some objects into memory, of course, but it also throws away those objects, and so you barely need any memory. The problem is that it's much more difficult. It's a lot more work to read a file using a sax parser than with a DOM parser. But it's doable, and I did it already, but I'm gonna do it again. So I'm gonna start now, and I'm gonna create a folder called my sax parser. I don't know, Wikipedia reader. All right, Wikipedia reader seems fine. And I'm gonna initialize a Ruby project here, which I usually do by calling, actually by checking out which version of Ruby I have installed on my system. I'm gonna go with the latest version available. So echo 3.0.1 to a .ruby version file. And then if I read it, yeah, there you go. And then I can already call bundle init and start putting some gems. So I'm gonna use Nokogiri naturally, and I probably wanna use only Nokogiri. And now I'm gonna install it, running bundle. And then I'm gonna create a new file. I'm gonna call it read xml.rb. I'm gonna put a bang here, and Ruby puts hello world, require the Nokogiri gem, and I wanna make this file runnable, and then I wanna run it with BE, which stands for bundle exec. I'm gonna just type BE, and there you go, hello world. It successfully loaded the library. So I kind of have a code on my left side, so I'm gonna be kind of copying it, not actually copying. So for a sax parser, the way it works is that you have to define a class. At least that's for Nokogiri. So I'm gonna call it a wiki reader, and then it has to inherit from no code GUI XML sex document. Although this is not gonna hold a document. I don't know why they call it like this. I'm gonna just do a initialize, and I wanna forward whatever comes here. Come on. Right. And then I'm probably going to initialize some variables later, but there are some magical methods here from no-code which I have to define, like start element, and then its name and attributes. So actually that's it. I don't need. I only need another thing here, which is to create a parser, and it's going to be no-code XML sex parser.new, and then gonna create a wiki reader. All right, and then I'm gonna do parser.parse, and let me I have to pass in the file, not the contents of the file, of course, but just the handle to the file, so the opened file. And this is where my file is. So if I run this now, again, what's going to happen is nothing. And actually it's not nothing, is that it is parsing the file. And it's going to take forever. I mean, it's going to take literally hours, I think. So that's not interesting. But what's actually happening is that while it is parsing the file, it is calling the Startelement method. So called Startelement with name equals name. Well, let me remove this. So I'm going to just print the name. Startelement. Let's make this shorter. And I'm going to print the name. So if I run this now, we're going to see a lot of this. All right. So a lot of this. And what's happening here, if you compare here the file, it has a MediaWiki, and then it has a site info, and then a site name, and then a DB name. And then if you compare here, what's happening is that there's a MediaWiki, a site info, a site name, and a DB name. So that's the same order. And then there's a base, a generator, and a case, and also here a base, a generator, and a case. And then there is the namespaces and the namespace. So namespaces and a lot of namespace entries. And after that, there's a page. So if you look at it, the last thing here is a namespace, which is this entry over here. And then there is this closing tags, and there's a page. And if you look at it, it goes straight from the last namespace to a page, right? Because what's happening here is that this function is called every time a start of an element is there present. And these are endings of elements, all right? And well, naturally, we have the attributes here. And let me just print some of them. And you see all these namespaces, and then key -2 case first letter, and there you go here, key -2 case first letter. All right. Also interesting is that we don't see this. So this media, this special, this stock here, they are not printed out here. I'm gonna go through that later. So it's calling Startelement. That's how a sock parser works. It's gonna call a callback method every time it sees something. And there's another method here. So well, to make it easier, let me open dash, which I use to read documentation. And here I have the documentation for Nokogiri, and I'm gonna look for start element. So it's the socks document start element called at the beginning of an element. Name of the tag and the attributes. And if I look at the methods here, I have also end element called at the end of an element, and the name is the tag name. So def end element, well, an end when the element ends, there's no way to declare any attributes there, so that's why there's no attributes. And what I'm going to do just to be able to debug it is I really want to remove these attributes here. Alright, now I want to print out the name, and oops, try it again. So run for a while. Well, site name, Startelement site name, and then here it's calling end element. I just put end, but anyway, it's called end element here of site name, because let me put this again, because site name begins here, and then there's this Wikipedia that we are not seeing anywhere, and then there's the end of site name, so just closing the tag here. So you see that this sucks parser is actually very simple, very simple. It just emits whatever it finds. So yeah, it said, well, I found a beginning of a tag, so I'm gonna call a function saying that there's a beginning of a tag. Well, I found the end of the tag, so I'm gonna call the function here that says that it's the end of the tag. All right. So what about this Wikipedia here in between? Well, actually in XML, this is a node. This is called a node. This is also a node. This declares the end of the node. This is not a node. This is an attribute, but these are all nodes. And the funny thing is that this is also a node. So this is a node, not an element. It's not a element, but rather just a node. Every element is a node, but not every node is an element. Anyway, what it actually is a text node, So if I go to comment characters, well, characters. So characters read between a tag. All right. Can be called multiple times given one contiguous string of characters. So let's declare these characters, and what's going to be there is the content, and then characters. I want to change this in here to end element. So printing out the content, and then running this again. Well, now we can see some content there. And what's funny is that now we see the start of the element media wiki, which is the first one. And then we see characters. And then we see site info and then characters. And then we see site name. And then we see characters Wikipedia. And then we see the end of the element site name. All right. So what is actually happening is that you see here site info and then characters. Well, of course, because between site info and the next thing, there is this. This is a line break and 1, 2, 3, 4 spaces, and that's a string. That's a valid string. And I even want to go and I want to know the length of this content. So after site info, there are 5 characters. Well, of course, Of course, there are 5. It's saying right here, and I can count them. I can count 1 line break, and then 1, 2, 3, 4 spaces. All right. Cool. So that's it. And what you're seeing here is maybe a little bit desperate. It's going to make you a little bit desperate, because this is the way you read a huge file. There's not much more than that. What this means, now let's say we want to read all pages. So we want to read all, whenever there's a page chunk, I want to go and say, well, here's a page. And I want to also extract the information inside this page. So it's going to be a title. I want to know the ID. I want to know whether it is a redirect or not. And when it is, I want to know where it redirects to. I also want to read the revision. And I'm going to assume here there's going to be only 1 revision maximum. Maybe 0, but not more than 1. And then I want to know the ID of the revision, the ID of the parent, the timestamp, and, well, let's say the text. This, I don't know this, but I don't know. I do want to know the text. So, yeah, maybe even the SHA-1. So this is incredibly a lot of work. And I did it already, and I'm going to do it again. So the way I did it was the painful way, in which I had to keep all the state of reading this. I did it in a very, very manual way. Another way that I think could be done. So the problem here is that, let's say I want to read a title. So you have to keep track. You're only going to have these callbacks, the start element. This is all you got. There's no more than that. There's only the start element, characters, and end element. There's no more than that. And just with these 3 calls, and also the initialize, you have to read the file. You have to be able to access the title of a page, know where a page begins and ends, and that's it. So there's a lot of state keeping. You gotta keep the state here. You gotta know where you are. You gotta know when you get the beginning of a title. You gotta say, okay, now I'm expecting next that it's gonna call characters 1 or more times. It could even divide, call characters for this and then call it a second time for the rest. Would probably never happen, but it's possible. It's saying that on the documentation. So, and then when the title ends, it's going to call end element, and you got to know, okay, we were reading the title, and now we want to store the information somewhere, because the next time it calls end element and we were reading a page, we want to say, okay, we finished reading 1 page, and here is the title, the redirect, the text, the author, the ID, the timestamp, and so on. So that's quite challenging. One way to do it that I thought, but I didn't do it, and I don't want to do it actually. It feels kind of cheating, but that's not a problem. Is to actually try from the calls that it's going to happen here, is to try to get this XML, rebuild the XML, feed it to Nokogiri, and then parse, because this is totally parsable. You could pass this to Nokogiri on a DOM reader instead of a SAX reader, and then it's much easier to access all these properties. Much easier. And the way that one would do that for this document specifically is just whenever you have a start element of page, you could start tracking, and then all other calls are gonna store somewhere all this information, the tags, the contents, and so on. And whenever you get an end element, if it is a end element of a page, then you get that save data, and you feed it to Nokogiri, to a DOM parser, and then extract the information from there. So that's one way. It would work for this specific document. But the way I did the painful way is because I wanted to also achieve a good performance. And I think for a good performance, that this method would not be the best performance that I would be able to get with Ruby. So I decided to do all the state keeping. And I'm going to kind of copy what I already have while I explain what I am doing. So what I need to do is I want to use a stack. I use a stack. A stack is just a pile. You put on top of a pile. You put something on top of a pile, and you can know what's on top of a pile. And I want to use a stack to keep the state. I want to know where I am. So I'm gonna call it the node. I'm gonna call it the node stack. The stack. So the node stack. I'm gonna call it state stack, because this is a stack that keeps the state. And a stack in Ruby can be done with just an array. I don't need anything else than that. And then what I want to do is, whenever I have a start of an element, I want to put that element on the beginning of the stack. So let's comment this out for now. And whenever I have an end of an element, I want to go to the stack, state stack, and remove. So this is going to add the element to the very end of this array, which is gonna be the top of the stack. And this is gonna remove the last element from the array, which means it's gonna remove the element from the top of the stack. And this is going to work. So I'm just piling up here the name of the elements. And what I want to do here is, whenever I have an end element, I want to say we are at, and then state stack. And sorry, I want to do this on the beginning. So we are at state stack join, and then I'm going to put a slash just to separate these things. And let me run this. And then you see I'm using here a slash to separate. So it's pretty obvious, I guess, what's happening here. So we are at MediaWiki. So that means we entered the first. Let me separate this. All right, that should be better. So here we are at MediaWiki. That means we entered this node. And here we entered site info while we were at MediaWiki. All right. So now we are here. And now we entered site name while we were at MediaWiki, and also in site info in this order. And then we left site name, and there's no message telling that, but since site name is not here anymore, no here to be seen, I know that we left it, and now we are on DB name. All right. So I think this gives a view, and the thing here also is that every single one of these is going to have MediaWiki on the beginning. because it's the root element. It's always going to be there. So I'm going to go and remove it from printing. Actually, what I want to do is that if name equals media wiki and state stack is empty, then just return, do nothing. And if I run this one more time, well, here we can see, and we can see this pattern, of course, because every page is quite the same thing. So it's going to be, we entered page, and then there's the title, the ID, the revision, and then the revision ID, and so on and so forth. All right. So with this, I think you can already see what we can do here. And I have this notation here. And if you think about, let's copy this. So I'm going to copy this. And I'm going to put this here and comment it for now. But what I want to do as well is I want to do it. I'm going to get a little bit more complicated. So I want to do a state. I'm going to make a class state. Node state. So node state. And it's going to have an initializer with a name and a attribute reader of name. And then it's going to put a name there and characters. Put characters. So it's going to have also characters, which is going to be an array. And characters is going to just add, it's going to add this here. All right, so node state. Now, instead of adding this, I'm going to add a node state. All right, and of course, I cannot do this anymore because I cannot join this. Instead, I have to map it to the name and then make a slash. So whenever we have characters now, we're going to check the stack and whatever is there on the top. So top node or current node is going to be this. So if the current node is empty, which should never happen actually, then we just return and do nothing. But otherwise, we come over here and then we say put characters. Put characters. All right. So if I run these again, nothing is going to change on the output. But now what happens is that we have some more data. We have these characters here being put here. So what we can do is that every time there is an end element, we can pop it, and pop not only removes the last element of the array, but it also returns it. So current node, or last node actually. So last node, or I'm going to just call node. And again, I'm going to return if this is nil. This should never be nil unless we are on the end of the document. All right, I have a node, and what do I do now? Well, I'm going to move these here to here and say we are at, and then here we have what I'm going to call a path. A path. So we are at path, and what I want to do is I'm going to say node content. So I'm going to say that a node can have a content. So it's going to have two methods here. Does it have content? That means that the chars are not empty. Not empty. And here the content is going to be everything together, which doesn't need any parameter. Alright, so that's, I'm going to call it content. So it's just going to join together all these strings, which I think most of the time is going to be just one element in here, but yeah. So we are path, and then if there's content, we're going to say content is node.content if there is content, and then run it again. Why didn't it work? Because I have to close this. Alright. Okay, current node. There's no such thing as current node. Of course, I changed name of the variable. And it's not printing anything. That's funny. And element state stack pop return if node is nil. There you go. So we see that we are at path. Well, there's one detail missing here, which is since I popped the last element here, I want to now edit again. So this is going to be one array. Yes. Alright. So there you go. Now we have the same thing, but I'm not seeing the content here. Why? Because I'm missing an if here as well. There you go. Software bugs. That's how it happens. Alright. Lots of content. So we are at site info, and there's a content Wikipedia. We are at site info site name, and the content is Wikipedia. What's funny here is that if you take a look at site info / site name, actually the content is Wikipedia. And if you look at site info / db name, the content is enwiki. And if you go a little bit further to a page, so we are at page and the content is just some white space, but also we are at page title and the content is anarchism, and there you go, here it is, anarchism. Where here, anarchism. All right, so what we can do here is we can start accumulating these attributes. So on the end element, I can say that if there is content, I can put a list of attributes. So I want to say, for instance, I want to capture all the titles. So I'm going to say here, if path is page title, then I'm gonna put a attribute page title equals where is it, the content of the node. However, if well, let me just print this just so that we can have an idea. Alright, so this is going to print the page titles. Alright, but what I want to do is I want to associate this title with the page, right? So the way you can do this is, and let me put back this debugging information, is that else if if the path is just a page, so here we are closing a page. Remember, we are an end element and we close the page. But when we were at a title, we store the page title. So that means that we can grab more information. And I'm gonna even go ahead and add some more here. So when we were at page slash revision slash let's say ID, we had page revision equals slash node content. All right. And then when we finish the page, we can say, let me actually comment this again. You can say page and then page title is page revision. I'm going to say revision rev ID, revision ID. Also important to do is to clean this. So we ended the page, we want to clean these attributes. Otherwise, they're going to be left over for the next iteration. So let's clean these things. And now let's read it. So there you go. Here we have, for instance, I don't know, August 13. I don't know what happened on August 13. But definitely the revision that we had here was this one. So here we can already start identifying attributes of this. So August 13. If I go to the Wikipedia, actually I can put it here and I have to replace August 13. Well, it went to Anarchism probably because that ID is from the Anarchism page. So this is gonna go to the August 13, edited on this date. So is this actually true that it was edited on this date? Well, let's grab the timestamp. So if path equals page revision and then timestamp, then the page timestamp is going to be the node content. All right. And I'm gonna add this to the clean list and say that TS, which stands for timestamp, is this. So August 13, which is here, was edited on 13 of July at 7:54. Well, 7:64, 13 of July 2019. That's true. So we are correctly capturing this information. And well, so this is a trick. Actually, this is not the way I did it before, but this is a trick you could use to read this XML file using a sax parser. Much easier than the way I did before. Probably not as performant, but anyway, it works and should be pretty fast. And I do want to measure the speed of this. Also, what I want to do is I want to finish this video soon because it's getting quite long. And well, I just want to complete it. I want to finish reading all the information available. And to do that, I'm actually gonna do kind of in a reverse way. So I'm gonna say which ones are the attributes that I want to read, and these are the attributes. So I'm gonna put them here, and I'm gonna uncomment and remove these we're at, transform these into a string, and say that this is the information that I want to read. And then I'm going to put a comma and say that attributes or page attributes is going to be this list. which is going to be frozen. And then I want to do it a little bit different. And I want to go, and instead of putting in a lot of variables, I want to have only one variable to store all these attributes. And I want to say that whenever we are starting an element, and then I'm going to say here that if the element name is page and the state stack is empty, because page is a child of MediaWiki, and since MediaWiki is not added to the stack, that means that the page is always going to happen at this step. All right. So when this happens, I want to create a new empty page here. Just create a new page. And the page is going to be a hash. That's fine. And whenever we end here the page, I'm going to say that page equals nil. And then I'm going to say also that if we are reading here, if page is available, then I'm going to say read page attribute, given the current or process page. And I'm going to say path, and what I also need is the node. No, process page. Page attribute. Page child. The node and the path. So node and path. Then I want to move this code to its own function down here. I'm gonna call it this private def it here, so it's more clean now. And not it's only more clean, but it's only gonna be called whenever page is not nil. All right, so it can also be called like this. All right, so the next step is that instead of comparing each element with an if here, what I'm going to do is I'm going to take these page attributes and redirect. All right. So these page attributes, and I'm going to say that, oops, I'm going to say that I'm going to go through each attribute, and I'm going to have the attribute name, and if the attribute name matches the path, right? So they are all in the same format with this slash here. It could have been a dot, could have been anything, but I just want to choose the dash, the slash. So if this is true, then we want to also break. So that means getting out of this loop, and we want to say that the page attribute name has node. So not node content, but rather node. Also, if path equals just page, if it is just a page, and well, maybe this could be an else, not necessary, but could be. So if this is a page, I want to print this information, page title, page revision, and page timestamp. And the way it's going to be there, it's that the page title is going to be at page, and then it's going to be page slash. Yeah, now the problem is, well, you can see the problem is that if you want to refer to this thing here, you gotta have the whole thing and then content. All right. So page revision ID. Well, I know that it actually is the revision ID, and the page timestamp is at page timestamp. I think actually it's at revision timestamp. Is it? Yes, timestamp. All right. So this is the page timestamp. And then we print it, and then we clean the page again. And there's something wrong. There's an end missing. All right. So if I run this again, it's going to execute the same thing. So it's already on B, and August 13, that's the date we had. So it's all correct. So it's reading all the information correctly, which is awesome. So yeah, and we also know that all the information is actually there. So I'm going to change these puts to say got a page, and then I'm going to go through all the attributes and print them. Value is going to be page, and then the attribute name. So this is a node, so it could be that this does not exist. So it's going to be content. And then I'm going to say that the attribute name is the value. All right. It's the value. Let's put an extra, well, not needed. And there you go, all there. So here's the first page, which was accessible computing. Its ID is 10. It has no, well, actually redirect's not going to have any content. The revision ID, it's here. Well, we have, and the text is here. So now we have all the information. And here is the Anarchism page, which also has all the information here. So yeah, it's there. It's all here. We did it. We did it. Totally did it. So I'm gonna wrap up this video by deleting this and saying that what I want to do next, I'm going to improve a little bit the code here, so that in order to refer to the elements or to the attribute names, don't have to use these slashes. And also, I want to actually go ahead and measure how many pages, I want to know how many pages per second this script is able to read, all right? And then later on, probably on a different video, I want to go and insert them on a database. And then I also want to do some benchmarks and talk about database. All right. Thanks for watching. See you next time.